Lab 2 free falling in the Newton's second law. It's important to understand the forces acting on objects during a free fall. The Earth exerts a force to its center called the gravitational force. That force accelerates everything in the Earth's surface about 9.8 meters per square seconds. Also, drag force and the object's shape and mass are clues to understand this kind of motion. I create a ball with a heavy paper wrapped in aluminum foil. This ball has a mass of 12.84 grams and approximately of 51 centimeters. I raise the ball about 2 meters high. The position vector 1 is 0 meters at 0 seconds. The velocity in this time interval is 0 meters per second. This video is captured in 30.20 frames per second. I import the video in Tracker. The parabolic negative slope of the graph represents the motion of the ball. The y-axis represents the position in meters and the x-axis the time in seconds. The total time is 0.497 seconds. All this data is important to create the model in Python. In Python, I edited the ball mass, the constant b and the total time. The net forces on this experiment is not 0 Newton. So I add the equation to ensure the correct values. The weight force equals the mass in kilograms by the 9.8 meters per square seconds and hat g. The position and velocity changes in each loop in the program by the forces acting in the system. The drag force acts against the weight, but in the first trial is 0. Model shows a similar motion and direction. The final position vector in the model shows 0, 1.21 and 0 meters. That values are without the drag force. I change the drag value in the constant b to 0.0010 and run the program again to ensure the correct final position value. After the adjustment in the constant, I perform the calculation of percent of error to avoid parallax. I exported the observed data and the model data to Google Drive. I create a table with the time and position with both data. The graph shows two slopes, one for the model and one for the observed data. The observed data is not perfect curve because the shape of the ball, the irregularities on the ball and the blur image can affect the values. I understand that the difference are not significant because is small. What if? What if I change the values of the constant b, or drag force? The arrows representing the forces and final position will be affected. As bigger drag, less covered distance by the ball by the same amount of time. Thanks for watching my videos.